For today, I can solve real-world problems using systems of linear equations. Read together, 1, 2, 3. Okay, so today's word problem is the last one of the series for applications in regards to systems. Today's will be a little challenging, more challenging than the rest because it requires reorganizing equations in different forms. So make sure as we're going through this, you stay focused because, like I said, this will be the most challenging one out of the rest. So, just to recap, systems of linear equations, by now you should know the definition by heart, right? So you never the definition of systems of linear equations? All right, so you should have said the set of two or more linear equations with the same variables. By now you should know an example, a non-example, and at least one or two hashtags. Okay? We started applying systems. I showed you a video of me going to buy some drinks at the coffee shop. From there I gave you the problem-solving strategy, which is cubed, which we've been using for applications, yes? We started with item and cost kind of problems with the one where I bought the spice chai and the matcha. From there we went to rag and bind sheets of felt and cardstock. We can apply it to other stuff such as flowers and so on and so forth. From there we went to one of your favorites, which is a rate and distance problem. Remember with the airplane? And then from there we did some practice on that, and then I showed you how it can be applied also to like going upstream, downstream, and any other problems that involves rates, such as a boat traveling on the water and such. From there, we went to your second favorite, which is mixture problems. The chemist mixes and so on and so forth. Second favorite. So from there, we did some practice of those, and we get now to number 8, the last time. Copy this down, please. Example 8 says, the sum of the digits of a two-digit number is 10. When the digits are reversed, the new number is 54 more than the original number. What is the original number? Copy that, and then I'll go over it. So once again, it says example 8. The sum of the digits of a two-digit number is 10. When the digits are reversed, the new number is 54 more than the original number. What is the original number? All right, so let's start by cubing this. I'm going to start with blue. And I'm going to circle important numbers. So the only important numbers that you see are what? 10 and 54 more than. Okay. In red, I'm going to underline the question. What is the question? What is the original number? Let's box important terms. Let's see from the beginning. It says the sum of the digits. That's important, right? Sum of the digits. And from there, which word is the most important out of all those? Sum, because it tells us to do something with the information that we have. From there, what else is important? Two-digit number. That tells us something important about this problem. Two-digit number. And then at the end, it says digits are reversed, and then we get a new number. Digits reverse, and we get a new number. There it is. So, we exclude anything else, and we're going to draw our table. So since we're dealing with systems, how many lines down? 3. 1, 2, 3, and 2 across.
You should stop back just a few minutes.
Thank you.
You should have a guide.
All right, here we go. So, writing pencils down, look up to the screen. You'll copy right after start setting this up because I want you guys to understand what we're looking at here. Okay, here it goes. So it's talking about one number, and it's a 2-digit number. How many digits? 2. That's why my columns, I'm going to start by labeling first digit, and you're just paying attention right now, and second digit. But now, in particular, now we need to write something here that relates to the 2 digits. If it's a 2-digit number, what place is this digit in? That is correct. This one we're going to label the 10th, which means this one, the second digit, is the... No. Okay, one second, you're missing it. It's a 2-digit number. This first number is in the 10th, so that means this number is in the... We're not talking about decimals. We're talking about a 2-digit number. Okay, for example, let's say I give you the number 23.
The 20.
The first number is in the tens. What is the other number in?
20.
Ones.
Oh, the
Ones.
second number in the...
So therefore, to make sure I use the same placement type of terminology, I'm going to say that this is units, tens, and units. This one will always be our total, okay? And you're just paying attention right now. Okay? So, it talks about, it says the question is, what is the original number? That means that this first row is going to be for my original, and you're just paying attention, which means that this second row is going to be my what? New number. Are we there so far? All right, so check this out. Since I do not know what my original number is, let me read this. It says the sum of the digits of a 2-digit number. So what would be the first digit? We don't know. So what can I label it? Or T. The second one is units, because we don't know. So can we label it? U. However, the sum of these, what is the total sum? 10. Are we there so far? Okay, before I continue with the next part, which is the part that confuses most of you guys, copy that up to right there. So, first we did our cube part. There it is. We did 3 lines down to a cross. We did first digit is in 10, second digit is in units or ones, and here's a total. This row is going to be for our original number. This is for the new one. The original number says the sum of the 2 digits is 10, because the is an equal sign, right? So since we don't know the digit, this one we just labeled T, this one U, and this one 10. So we're done with the first row. This row right here, we're done up to right here. Let's go to the next row. It says, when the digits are reversed. So pay attention to this part. Writing your pencils down. Here it goes. When the digits are reversed. So what digits were originally? T and U. When they're reversed, that means this one would be what? U, and this one would be T. Are we there so far? Okay? And then it says, the new number is, that means it's equal to 54 more than the original. What was the original? T plus U. So watch, T plus U, but 54 more is plus 54. However, pay attention to this part. Ready? This one came from the units, and now it's in what place? Tens. So in order to distinguish that this is in the tens spot, I'm going to write a 10. Are we there? Over here, from the original, this is in the tens, but just so that it can be written in the same format as this one, the first digit would be what? Times 10. Same format. Copy that.
I hit my blood now.
Thank you.
Now it's blood. I don't know if that's blood or what. Yes. Blood. I don't know what it's what is it? Where, right here? Silver.
All right. So let's see our two equations. Here it goes. What's my first equation? T plus U equals 10. What's my second equation? 10U plus T equals 10T plus U plus 54. Are we there so far? All right. However, look at the second equation. We have variables on both sides of the equation. Can we get them all on the same side? So what do I do here?
You subtract
10T and subtract U. So let's align it over here. Subtract U, subtract 10T. We're left with 54 on this side equals 2. Let's see. This is 9U and negative 9T.
And then you divide by 9.
Okay, hold on.
Oh, man.
We bring down the first equation. Cooper, step aside, please. Thank you. So look at this one. Instead of writing T plus U equals 10, look, what's the first variable on this equation? 9U. So what do I write? How would I write this one here? U. Okay, look at this. U plus T equals 10. All we did is move them around. What property allows us to move them around? Commutative property of addition. That is correct. So now, by looking at it, if I was to use elimination, look at these two. What would be my next step? Tell your neighbor, please.
You would multiply that one by negative 9, or you can multiply by 9 if you want to. It don't really matter. Multiply that one by 9.
Okay, Andrea, what do we do? Multiply the bottom one by 9. So let's distribute. So this becomes 9U plus 9T equals 9D. Is everybody following? We eliminate the T's, and we're left with 18U equals 90 plus 54. 144, bless you. Lastly, we divide by 18. Divide by 18. U equals
6.
And it's not 6. Stop guessing, do the division, please.
But I thought 9 goes in there 12 times, so half of that is 6. So then how is it now 6?
Luker. 8 is correct.
Fake. He's lying.
Okay, tell your neighbor what to do to solve for T from there. Okay, so which one do I use? Helena. Tell me what to write. That is correct, and we substitute instead of U, we substitute the 8. So this is T plus 8 equals 10 minus 8 minus 8. T equals 2. So the T stands for tens digit, and the U stands for units or ones, right? So let's look at the question. Let's answer the question. It says, what is the original number?
82. Oh, yeah.
The original number is 28.
Michael Jordan.
10 cubed. Now let's see if it's true. Okay? Let's see. It says the sum of the digits of the two-digit number. So we said that the two-digit number was 28. What does the sum mean? That we add these, right? What is 2 plus 8? 10. Okay, so that's true so far. But then it says, when the digits are reversed, when we reverse them, what would be our new number? 82. It says that the new number is 54 more than the original. What was the original? 28. What is 28 plus 54? That's 70. That's 82. Yes, it does work. Okay? So let's see. What's going to be the challenge in this setup? The challenge is not the 3 lines down to across, not the tens, the units, the total, original, or new. It's not the tens plus u equals the number. It's going to be this part right here. Because when it says reverse the digits, you write u, t, and then 54 more than the original, you write the original t plus u equals 54, but then remember to change the first term to base 10, or to the 10th place by multiplying times 10. Does everybody see that? All right. You're going to do one by yourself, please. There he goes. Copy that one. Yes. Yes. Copy that. It says the sum of the two-digit number is 5 when the digits are reversed. The new number is 9 more than the original number. What is the original number? Copy that and go. See if you can do the as much as you can without looking at your notes. All right. Let's see. I gave you a couple minutes. So first things first, 3 lines down. So across. And I'm continuing with the table after you cubed it already. Yeah. All right. So then you should have labeled this one tens, units, total. Okay. And then you probably did another label here, first digit, second digit, so on and so forth. From there you did original, number. Second one is new number. For the original number, we don't know what the tenth digit is, so we just label it T. We don't know what the units digit is, we label it U. But the total is what? 5. From there it says the new one, the digits are reversed. So it means you did U and T. But then it says that it's 9 more than the original number. The original number was what? T plus U, and 9 more is plus 9. But then what did we say? That this one, now that it's in the 10th digit, we're going to write what? 10U. And if we do that to this first term, we need to do that to this term.
Yeah. I wrote 5.
Hands if you did up to right there. Okay, good. Now we can write our system. T plus U equals 5. And then the other one is 10U plus T equals 10T plus U plus 9. Then we said, okay, before I start solving, I'm going to simplify this second equation by getting all the variables on one side. So what do I do from there? Zachary. Zachary? No? Xavier? Minus 10T and minus U to both sides. Minus U minus 10T. To get these to the other side, we're left on this side with 9 equals, and this is 10 minus 1, that's 9U. 1 minus 10, that's negative 9T. From there, we're going to bring the first equation down. And we need to align the variables. So I do what? U plus T equals to 5. At that point, what do I do to the second equation? Multiply times 9. So we get 9U plus 9T equals 45. All right. What cancels? The 9T. So what is 9U plus 9U? 18U equals 9 plus 45, that's 54. Divide by 18, divide by 18. U equals 3. What do we do from there? You substitute it into T plus U equals 5. Instead of U, we write 3. T plus 3 equals 5, minus 3 minus 3. T equals 2. Bless you. The original number is 23. Thank you.
23. Kobe Bryant. Crazy.
Okay. How we doing? Let's do another one. Here we go. Example number 10. This one you don't need to copy the whole problem. Start from the table. I'm going to leave it up there. And it reads, the sum of the digits of a two-digit number is 11. When the digits are reversed, the new number is 45 more than the original number. What is the original number? Start from the table. Set up your system and solve. Try to do it without looking at your notes. All right, ready, go. Copy that. Okay, let's see. 3 lines down. 2 across.
You hear that?
Here we go. 10 units total. Original number. New number. The original is T plus U equals 11. The new number is U plus T equals T plus U plus 45. However, what did I ask you not to forget? To this one times 10 and this one times 10. So my system, T plus U equals 11, and 10U plus T equals 10T plus U plus 45. So from there, we cannot leave the second equation like that, so we bring all variables to one side. Minus 10T and minus U minus 10T. We're left with 45 on this side equals 2. This is 9U minus 9T. From there, we bring this one down, and we would label U plus T equals 11. From there, we multiply the second equation times 9. That leaves us with 9U plus 9T equals 99. So from there, eliminate the T's. We're left with 18U equals 144. From there, divide by 18. And we're left with U equals 8. From there, we take T plus U equals 11. T plus 8 equals 11. Minus 8 minus 8. T equals 3. Therefore, the original number
38.
is 38.
Whose number is 38?
10Q.
Whoever you just said.
Okay? One more? Just follow the process. Now, check this out. Some of you, some of you are struggling already at this point because this one requires a lot of concentration and processes. And this shows some of you that have not been doing your work consistently now. Your brain is not being able to handle like all these processes. Yeah. One more? Home play for tonight is your study guide. Study guide 5A. So Monday, pay attention to this part. Monday we take our cumulative assessment. So those of you that are coming to Saturday Academy, do not do the study guide tonight, but bring it with you tomorrow because we're going to use that for the Saturday Academy. Those of you that are not coming, that are having your, I know some of you are going to the Mesa competition or have other things. I'm going to try and record the Saturday session and upload it into the YouTube channel so you can go at night and see if that helps you go through the entire study guide. Okay? Okay. So make sure before you leave, you pick up a study guide over here from the front. Good weekend, guys. See you guys tomorrow. Bye.